So now another specific thing with arrangements is sometimes doesn't tell you exactly how many you're picking out. So it will tell you that there are 5 cupcakes, for example, and you want to arrange them, but it doesn't tell you, am I arranging 1, 2, 3, 4, or even 5 cupcakes. So in this case, you just have to assume it's any of them. That means you have to assume there's 1, 2, or 3, or 4, or 5, okay? And because you notice I'm using the word or between them, that means I'm adding the number of arrangements together. So this, I think, does look a bit complicated, but I'm sure it's going to make sense to you once I go through the questions. Just remember, we're going to be working with, this is when we have the any number arrangements. So we don't know how many numbers or cupcakes that we're taking. So the first question we're going through is worded like this. So integers are formed from the digits 4, 5, 6, and 9. Find the number of arrangements if repetitions are firstly allowed or not allowed. Now, note here, it just says integers are formed from these digits. So we can't assume it's going to be 4-digit integers. It doesn't specify that, does it? That means I have to say it's either going to be a 1-digit integer, a 2-digit integer, a 3-digit integer, or a 4-digit integer. Can you see that? Because it doesn't specify, I have to assume it could be any of those. So let's do repetitions are allowed first, which means not permutations. So I need to consider all of these. So when it's 1-digit integer, well, there's only 4 options. When it's a 2-digit integer, that'll be 4 times 4, yeah? 2 digits, so that's why it's 4 squared. 3-digit integer, 4 times 4 times 4, which is why it's 4 cubed. And 4-digit integer is going to be 4 to the power of 4 in the same way. Now, so it's going to be 1-digit integer or 2-digit or 3-digit or 4-digit. And that's why I add them all together. So I get 4 plus 4 squared plus 4 cubed plus 4 to the power of 4, okay? And all together, there's 340 arrangements for integers formed from these digits. So can you see, it doesn't specify the number of digits in the integers, so I have to assume it can be any of those. So that's the most important point. All right, let's work with repetitions are not allowed. So I know it's going to be permutations because order is important, repetition not allowed. So exactly the same way, I just consider each of these ones. So firstly, I consider when it's a 1-digit integer. So that means that's going to be 4p1, right? So 4, and I'm going to choose 1, but it's in arrangements. So it's going to be permutations. 2-digit integers, 4p2. 3-digit integers, 4p3. 4-digit integers, 4p4. Easy, right? And because it's 1 digit or 2 digits or 3 or 4, it means I add them all together. Yeah, you can just put that in your calculator and you get 64 ways of arranging that. All right? You can see this is actually, it's exactly the same ideas of everything we're going through. The only difference is we're kind of doing like 4 little questions in one, and then we just add them together at the end. All right? So remember, be on the lookout for this because it's really easy, and I see it so often that you look at this and you think, oh, okay, they've given me 4 digits. It has to be a 4-digit integer. It doesn't specify, so you have to assume it could be any of those. All right, makes sense? Good. Let's go on to question 9 now. So in question 9, we have this question, which is how many arrangements can be made from 4 different colored balls taking any number at a time. So this one's less ambiguous, at least it's telling you straight out, taking any number at a time. So you should note straight away, all right, I'm going to have to consider when I'm taking 1 ball, 2 balls, 3 balls, or 4 balls. We're working with an object here, so we assume that it's not replaced unless it specifies so, okay? It's not replaced and arrangement, so order is important. I'm working with permutations. So first of all, I want to consider when I'm just taking 1 ball, that would be 4p1. When I'm just taking 2 balls, will be 4p2. 3 balls, 4p3. 4 balls, 4p4. And because you could be 1 or 2 or 3 or 4, that means I add them all together like that, yeah? And which equals to 64, all right? So it's actually really nice and simple, even though it looked a bit complicated on the first page when I first explained it. You just think about it as each one of these and add them together. All right, let's go on to question 10 now. So here, we're told that numbers less than 4,000 are formed from 1, 2, 5, 7, and 9 without repetition. How many such numbers are there? Now, this is interesting because you have to consider how these numbers can form numbers less than 4,000. So 1-digit integer, it's always going to be less than 4,000. 2-digit, always less than 4,000. 3-digit, always less than 4,000. 5 digits, always bigger than 4,000, so we don't have to consider that. Now, 4-digit is really interesting because it only works for some of them, all right? So just keep a note out for that. Doesn't specify how many digits, so we have to work out with all of them. So like I said, with 1 digit, they're all going to be less than 4,000, so we can just say 5p1. 2 digits, all less than 4,000, 5p2. 3 digits, all less than 4,000, 5p3. Now, your 4 digits, let's think about it in a diagram. If you have 5,000 something, it's going to be bigger. 7,000 going to be bigger, 9,000 going to be bigger. So the only two numbers that you can have to start off your 4-digit integer is 1 or 2, yeah? So there's actually only 2 numbers that can go in there. Now, once we've used up one of the numbers, because this says without repetition, that means there's going to be one less number to go here. Any number can go here except for whatever's used there. So how many numbers can go here? Good, it's 4, yeah? Because there's 5 altogether, but I've taken away 1. Now I've taken away another 1, so there's 3 numbers left. Taken away 1 more, 2 numbers left. Can you see how we did that? Good. And then we just consider it as we normally would for this, which is this is 2 times 4 times 3 times 2, yeah? So this here is just 2 times 4 times 3 times 2. Now, because it's or between all of them, I just add them all together. So add this and then add that. Look, it's really up to you. Some people find it more comfortable to just work out that and then work out this and add it together. But as long as you understand the concept of what we're doing here, you should be okay. So you can either work it out separately or together, and you'll get 133 ways in which these numbers can be arranged. Now, this question, you have no idea. If I gave it to students, I can guarantee you at least 90% of them would get it wrong. So if you can understand how to do this and just to read the question here, you'll be better off than most people. So importantly, it doesn't specify how many digits, so you have to work with all of them. And the other really new thing here is we have to consider in the 4-digit numbers what numbers can actually go in the first digit for it to be less than 4,000.